Hey, welcome back. My name is Sushant Satish, and I am your instructor for this AZ-104 Azure Administrator Certification exam. We have just finished Module 6. Module 6 was all about network traffic management. And in this video, we're going to test the knowledge on what we have learned so far in the previous lesson. Let's look at the question number 1. Which of the following two features of Azure networking provide the ability to redirect all internet traffic back to your company's on-premises server for packet inspection? We need to select two answers, which is going to complete the whole solution. So what are these two features in Azure networking which can provide you this functionality? Is it user-defined route? Absolutely correct. Is it cross-premises network connectivity? Definitely wrong. Is it traffic manager? No, traffic manager provided different functionality altogether. Is it forced tunneling? Absolutely correct. And not system routes. So user-defined routes and forced tunneling are the correct answers. You can use forced tunneling to redirect internet-bound traffic back to your company's on-premises infrastructure. And forced tunneling is commonly used in scenarios where organizations want to implement packet inspection or corporate audits. And forced tunneling in Azure is configured via Virtual Network User-Defined Routes or UDR. Your company provides customers a virtual network in the cloud, and you have dozens of Linux virtual machines in another virtual network. You need to install an Azure load balancer to direct traffic between the virtual network. What should you do? We have learned about this when we talked about the load balancer. So which load balancer would you choose here? Because you need to redirect the traffic to the right virtual network. So do you install the private load balancer? Definitely not. Is it the public load balancer? No. You need to route the traffic to an internal virtual network. So is it an external load balancer? Absolutely not. So the correct answer is install an internal load balancer. Azure has two types of load balancer, public and internal. An internal load balancer directs traffic only to resources that are inside a virtual network or that uses a VPN to access Azure infrastructure. Let's look at question number 3. Your company has a popular regional website. The company plans to move it to Microsoft Azure and host it in Canada East region. The web team has established the following requirements for managing the web traffic. So what are these requirements? So the requirements are evenly distribute incoming web requests across a farm of 10 Azure VMs. Support many incoming requests including spikes during peak times. Minimize the complexity and minimize ongoing cost. Which of the following would you select for this scenario? We just need to select one. So based on all these requirements, what do you think is going to be the right Azure solution which you can implement? Is it a traffic manager? No, traffic manager is to route traffic based on a particular routing method. Is it application gateway? Definitely not. It's not Azure Cloud Services. So the correct answer is Azure Load Balancer. In this scenario, the requirements call for load balancing of website with minimal complexity and cost. The website is in a single region, which rules out Azure Traffic Manager, which is geared towards a distributed web application. And Azure CDN is complex and expensive, and it is best suited for delivering static web content at various locations worldwide with maximum performance. And Azure Cloud Services are suited for applications and APIs, not for this scenario. So the correct answer is load balancer. All right, so let's look at the question number 4. You deploy an internal load balancer between your web tier and app tier servers. You configure a custom HTTP health probe. All right, so that's the keyword here. Which two of the following are not true? So please make sure you understand this. So we are trying to find which scenario is not appropriate in this sentence. And we have to select two false answers. Okay, let me read out each statement to find out which one is not true. The load balancer manages the health probe. Absolutely correct. So that is not the right answer. By default, health probe check the endpoint every 30 seconds. That is not true because the health probe checks the endpoint every 15 seconds. The next statement is the instance is healthy if it responds with HTTP 200 error, which is absolutely correct. So we learned about that when we learned about the health probe in load balancer. You can change the amount of time between health probe check. Absolutely correct. You can definitely modify that. And the last statement is you can change the number of failures within a time period, which is wrong. You can change the number of consecutive failures, but you cannot specify a time period for the failures. Let's look at question number 5. Which criteria does application gateway use to route requests to a web server? So what is that criteria which Azure Application Gateway use? We need to select one statement from this. Is it the user authentication information? Absolutely not. The region in which the servers hosting the web application are located? No, that is traffic manager. Is it the IP address of the web server? That is the target of the request. No, that is a different routing method altogether. So the correct answer is the host name, port, and path in the URL of the request. Azure Application Gateway uses the host name, port, and the path in the URL of the request. Which load balancing strategy does the Application Gateway implement? You need to select one answer. Is it distribute requests to each available server in the backend pool in turn, round robin? Absolutely correct. So we hit the jackpot. So the first statement itself is correct. So application gateway distribute requests to each available server in the backend pool using the round robin method. So that's the strategy application gateway implement. You have several websites and are using traffic manager to distribute the network traffic. You are bringing a new endpoint online but are not sure that it is ready to accept a full load of requests. Which traffic manager routing algorithm should you use? You need to select one. So what's the algorithm you can use for your website to distribute the network traffic to accept the full load of requests? Is it round robin? Definitely not. Not the priority, not the geographic one. So the correct answer is weighted. You will use the weighted routing algorithm. This will put the endpoint into the rotation with a minimum amount of traffic. Your company has a website that allows users to customize their experience by downloading an app. Demand for the app has increased, so you have added another virtual network with 2 more virtual machines. These virtual machines are dedicated to serving the app downloads. You need to ensure the additional download requests do not affect the website performance. Your solution must route all the download requests to the 2 new servers you have installed recently. What action will you recommend? You need to route the traffic to the new servers you have installed. So what is the routing method you would choose? We just need to select one answer. Is it adding an application gateway? Definitely not. A routing table is not going to resolve the problem. It is not going to resolve the problem by creating a local network gateway or a user-defined route. So the correct answer is configure the traffic manager. Traffic manager lets you control the distribution of user traffic to your endpoints running in different data centers around the world. And the traffic manager uses DNS and can route traffic to your two new download servers. Let's look at the last question. You are deploying the application gateway and want to ensure incoming requests are checked for common security threats like cross-site scripting and crawlers. To address your concerns, what should you do? So we learned about this when we were talking about application gateway. So the correct answer is install the web application firewall. The web application firewall is an optional component that handles incoming requests before they reach a listener. The web application firewall checks each request for many common threats based on the Open Web Application Security Project or OWASP. Alright, so that concludes the module 6 that was all about network traffic management. In the next video, we're going to start a brand new module, and the module is called Azure Storage. So I will see you on the next video. Till then, take care.